Hey everybody, how's it going? So today we're going to be working on an A1708 Macbook Pro that appears to not be turning on. It's having an issue with charging. I'm going to open the bottom up out of this machine. We can take a look on the inside and see if we can figure out what's wrong with it and make it work again. On average, how long does it take you to spot and solve an issue in a new machine? How long is a piece of string? On average, how long is a piece of string? By the way, everybody, something that I got to show you all on screen here. Something that I'm actually pretty excited about. Check this out. We've got the amazing Jesse Cruz, who is contributing to the Repair Wiki in a really cool way. Look at this page. This is for the iPhone 7. There's much more to come. Look at this troubleshooting section. Look at this. Look at this. Is this not amazing? Look at the audio I see. Well, look, he's got pictures of the jumpers and how you run them and all this different stuff. The pads, like the symptoms and the problems. This is amazing. So I just want to give a big shout out to Mr. Jesse Cruz. This is really cool. We're finally getting people who are willing to contribute content here to the wiki and get it done. And I am happy to see him doing it. You can check out his company at vccboardrepairs.com. That's vccboardrepairs.com if you're interested in checking out someone who's pretty good at this type of work. And Repair Preservation Group is happy, humbled, and honored to have him on board contributing shit like this, because this is really nice. You can, and this is a common question, can I post other type of stuff here? Yes, you can. Don't ask me to post it, just post it. Don't ask, just make a page. Don't ask, just make a page. If you're good at what you do, if you are good at repairing whatever it is you work on, don't ask me to add it, just add it. You could look at this. We got medical equipment, drones, 3D printers, cameras, laptops, desktops. So, like, don't ask. Don't ask. Just do it. Just do it. Look at this. Just do it. Do it. This is my MacBook page over here, and we continue to add to it with each passing MacBook that we work on. Do it. All right. Let's open this machine. Rich Rebuilds might do a Tesla page. That would be cool. Ew. Gross. All right, let's take a look inside this. Ew. 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 The fan is brown. Come on. It's fucking disgusting. God damn. Okay, be right back. I gotta open the door of the store. I'm gonna blow this out outside. Look at this. It made my mat dirty too. My mat even got dirty. Look at the fan. It's still gross. Okay. Let's take the board out of the case. John, yeah, it sucks that they didn't have more Clinton in the video, and Clinton didn't get credited in the video. So let's see what is going on with this machine. Now, the customer claims it doesn't charge. Now, I'm not even going to plug a charger into this. Let's see if you guys have an idea as to what. Why do you think this machine's not charging? Look at that charge port. Look at the filth on that charge port. This has to be a meme. What the hell? Is that... Okay, we're going to turn this around a little bit. One thing to know anytime you're doing this type of work is you want to make it so that you're comfortable. Nobody cares if the board is comfortable. What matters is that you're comfortable. So I'm going to take a knife here. Unfortunately, the knife is not going to be comfortable because the knife's going to be touching this board. Do this. Now you see over here you got liquid. Similar to the last video I did where you had the trackpad, where you had the two pins from the trackpad connector that were touching each other due to corrosion. You may have the same thing going on over here. So I don't want to use alcohol and a Q-tip until I've actually gotten rid of the stuff that's on top. You're going to have to scrape. But then once the scraping is done, then I'll do this. And one thing it's important to tell is that I'm not going back and forth with the Q-tip. I'm rolling it around so that any of the dust of the hairs and the fibers wind up back on the Q-tip rather than on the cable, the connector, the chip, the port, or whatever it is that I'm Q-tipping. Yes, I do use Q-tips. I don't spend a crazy amount of money on, like medical Q-tips or anything like that. This is just your boring-ass Q-tips that you can get at Walgreens or CVS or something. Now we're going to do the other side of it. Again, a little bit of scraping in case any of that stuff is caked on there. And then once you've done yours, like filing your nails. Joanna Stern would disagree. Just like filing your nails. This board will obviously go through an ultrasonic cleaner as well, and that'll do a much better job of getting rid of the little bits and pieces of this because it heats the liquid to 65, 70 Celsius, and the Branson EC with cavitating action does a really good job of getting off the last bits of everything that were left on. Okay, then the next thing I want to do is I want to take a look at the charging circuitry area. And there's a little piece of poop. Look at that. A little piece of green poop over there. Now, does anybody know how this machine charges? Who in the chat knows how this machine charges? Can you walk me through it? Walk me through how this machine charges. By the way, if you are kind of curious and you're not really sure, you don't have a lot of answers to things like this, you can actually go to the repair wiki where I've put all this stuff, and you can find this board, which is an 820-00840 right here. And then you find that, and it will give you a list of different things. This is available for free. And what makes us able to offer this to you for free are people that are willing to contribute to it, like Jesse Cruz or like myself, and I wrote all this stuff. So if you finally wind up learning how to do difficult repairs on in-demand devices, pay it forward. Contribute to the wiki so that other people can learn. So let's go over this a little bit. So we're going to open up a schematic for an 820-00840 board. And we're going to go through it together. Now, this charges using a USB-C charger. USB-C chargers are different than many other forms of charger because this can put out multiple different voltages. So your standard laptop charger, this may always just put out 20 volts or 18 volts. Boring. USB, from your computer, that's always putting out 5 volts. They're boring. USB-C, 5 volts, 9 volts, 20 volts. You can use this to charge a GoPro. You can use this to charge a GoPro at 5 volts, a phone at 9 volts, or a laptop at 20 volts. So it's going to have a conversation with the computer before it turns on to figure out what it is. What are you? So that it knows what is appropriate to do. And it's going to do that on a particular data line. So let's find that. Now, if you take a look at the schematic in the board view, this over here is going to be our charge port. J7330. If we just take a look at the board itself on the desk, this is where you plug the charger in over here. See that? That is this over here. So we just take a look at that charge port. Now, there's going to be a data line on this charge port. You got a lot of different things in this charge port. So you have 20 volts over here, but you're also going to have a data line, CC1 con. CC1 con. That is going to go here, where it then goes to this chip, U3100. So what is U3100? U3100 is a Texas Instruments CD3215. And this is a USB-C port controller. We're going to just put this on the screen, full screen. This is a USB-C port controller. This is going to control this transistor opening or closing, which is going to allow the 20 volts from the charger to go through and become a main power rail in the computer over here. But further, this is going to speak to the charger and say, I'm a MacBook. I don't want 5 volts. I want 20 volts. What are you doing only giving me 5 volts? I need 20. I'm a MacBook. Now, on most of these schematics, particularly for Apple, you'll notice that the voltage rails that power a chip typically tend to show up on the top. So over here, on the left and the right, you have a bunch of different signals. But on the top, you're going to have a bunch of different voltages. And here you have VIN. VIN or VDDIO or VCC, anything like that is typically voltage that's coming into the chip to turn it on. VIN 3V3. That is going to be the voltage that we need for this to turn on. So VIN 3v3 is very similar to, let's just take something off my desk, for instance, my microscope. So my microscope over here, this is my microscope. This is my microscope camera that allows you to see everything. This, it would be the VIN port. See this? I have here where I could plug in a power supply. So that would be the VIN port of my microscope. And when I plug my charger, what am I, a fucking idiot? When I plug my power supply in there, I get a green light to turn on it. That tells me that it's on. Now, the same thing is true here. In order for this USB-C port controller to do its job, PP3v3_G3 hot needs to be present. This power rail always has to be present. So this is the first thing that you need before you can expect to get 20 volts in the charger. And the way that we can tell if the charger is working is with this USB-C amp meter over here. This USB-C amp meter is going to tell us when we plug it in whether we are getting 5 volts or 20 volts. And this over here says 5 volts, taking 26 milliamps, but it is not going up to 20 volts, so it's not able to communicate properly. So one of the things that I would do in this instance, if I didn't have eyes, if I were blind and I hadn't already seen that there was very, very obvious evidence of liquid damage over here, is I would check to see if PP3v3_G3 hot is present. Also, if you're someone who has difficulty with spotting liquid damage, do refer to a page on the Repair Wiki, Visual Inspection for Logic Board Repairs. This is a detailed guide on how to tell when there is corrosion, how to tell when there's liquid damage on a board, even if it's been cleaned already. So for instance, you can see over here, I go into detail with a MacBook DCN board and I show you how to tell. This is a good point over here. That is a good point. That is bad. This looks terrible, but actually conducts. This doesn't look as bad, but it actually is worse because it has less conductive material. This works, but will be bad later. This entire page goes over how to tell whether or not the liquid damage you're looking at is liquid damage that's bad or liquid damage or it's just something that doesn't matter at all. This is always going to be something that you need to be able to do. So I would highly suggest taking a look at this page, and if you have examples that you can add to it, again, by all means, if this, if these guides, if these videos help you, please, please, please do pay it forward by putting content onto this wiki. Everything that you can see on this page is stuff that I have contributed myself, as you can tell, because it's all in Microsoft Paint, which looks like shit, which is really only something a dumbass like me would do to begin with. But if any of this stuff helps you to learn, pay it forward by contributing to this so that other people can learn easier in the future from information that you make available. That's what Repair Preservation Group is about. Now, if I didn't see that liquid there, what I would do is I would go to my schematic and my board view, and I would try to find PP3v3_G3 hot to see if that was present and being created, because that is a precursor to our USB-C port controller working, which is a precursor to getting 20 volts in the charger, which is a precursor to the machine turning on. So I'm going to plug in this charger over here for a moment. I am going to look on the schematic in the board view and see where PP3v3_G3 hot here is. Okay, it's over here. PP3v3_G3 hot. It's this little resistor over here is a resistor sitting between the main power rail PP3v3G3 hot and the chip itself. This is a 0 ohm resistor, so it's kind of just acting like a fuse. So we're going to see if we have PP3v3_G3 hot, and a good place to measure it is right over here on this resistor, or we could also measure it right over here above the chip itself. So let's just take a look above the chip itself, right over there. Let's see what we get. Okay, so I'm going to turn the multimeter on the screen, and we are going to measure, and we're going to see what we get at this point. I can measure at, this is PP3v3G3 hot, and this is after it passes through the resistor, so I can measure on that big cap over there. I'm going to turn on my multimeter software, which is programmed and engineered by the amazing Paul Daniels, who comes from the tyrannical world of Australia. Hopefully. And see what we have. So I am going to get this on the screen. And let's see. Do you think we have PP3v3_G3 hot? Let's see. I'm going to measure and check. Okay, 3.41 volts is present. So we have 3.41 volts. So if we have 3.41 volts, that's close enough to 3.3 volts. That chip is getting the power that it needs to turn on. That is not our problem. At that point, then I would ask, is the chip good? And again, as you can see over here, if you had eyes, you can see that that is not good. Now, sometimes you can reuse the chip that's there. Simply get rid of some of the corrosion, and it will work again. The fact that there is green outside of here may not even be our problem. The problem may be that there is corrosion under the chip. So if there's corrosion that I can see right next to it, this may have corrosion under it that is shorting one thing to another. So one thing to understand is that this chip over here is called a ball grid array. So think of it like, instead of a chip where you have a bunch of legs that you can see, like a spider where you can see the electrical contacts, this chip has it's kind of like a bunch of marbles underneath it. So the chip is sitting on top of a bunch of marbles that then conduct electricity to the board. What this does is, instead of only having legs around the perimeter, it has a bunch of legs under it. So you can have a lot more connections on a chip. That means you can have a more miniaturized board design, which is great. The downside is that it makes it a little bit more difficult to tell if there's any sort of corrosion under there. So we are going to, first thing is try to understand, this is a really important thing to understand when you're learning from scratch. So what we have is we're stuck at 5 volts, we're not going to 20, and it's stuck at 20 milliamps. And this is the resistor that's corroded, right? So what I'm curious is to look at what these two resistors here are actually for, because I want to create an association between the symptoms that the machine has and those resistors being green. Because here's the thing. You're not always going to have a machine that's dead because of liquid damage. Sometimes you may have a machine that's dead for a different reason. Now, every single time, God gives you the gift of a liquid damage board that's not yours. You want to learn from it. So what you do is, let's just plug the charger in. And now I'm going to try and associate what the symptom is that I have, what the board is doing with those resistors. So 5 volts, 26 milliamps over here. 5 volts, 26 milliamps over here. We're just going to plug this in. Plug it in. And, okay, now let's see what those resistors do that are corroded. Because now I'm going to learn what this data line is for. See? This is an important one. So this is a 15 ohm resistor that sits between the USB-C port controller, our CD3215, and this Thunderbolt chip right over here. This is a resistor that goes to another resistor that goes to this Thunderbolt chip. So now what I've learned, if I reflow this, if I replace those resistors and this works, now what I've learned is that in order for me to get 20 volts in the charger, I not only need these two chips to work, but they also need to have a pathway by which they can speak with this Thunderbolt controller IC. This chip over here, U2800, even though it doesn't look like it has something to do with charging, may actually have something to do with charging. And this is something that I learned because it's liquid damage. So where this helps me is that when I get to the next one machines like this, where there's no liquid damage and it's not charging, I now have in my knowledge base that U2800 is essential for charging. So I don't always learn how everything works by just reading a manual that someone leaked from Apple that says, here's all the things that need to work, here's how you troubleshoot the machine. I don't have access to any of that. And the schematic, while telling me what's on the board, is not a troubleshooting guide, it just tells me what's there and where it goes to. The rest of it I need to make with my own brain. And the way that you create these types of very detailed troubleshooting guides is by, when you have a problem, when you see that there's corrosion on this little part of the board, I don't want you to just fix the corrosion. I don't want you to just Q-tip it. I don't just want you to replace it with stuff on donor boards. I want you to record in your mind, in an Excel sheet, and particularly on my wiki, here's the symptom that we had, here's the section of the board that was corroded, and when I fixed that corrosion on this section of the board, this changed. So this section that was corroded is responsible for this. Make those associations in your head. They're very important. So I'm going to clean that stuff off over there. But after I clean that stuff off, I'm now going to make an association in my head that that chip, that Thunderbolt chip over here, this USB-C chip, this U2800, is something that's necessary for charging. Okay? So what I'm going to do here is I'm going to give this a reflow. And we are going to put a little bit of flux on the board. So just a small amount of flux, and then we're going to get started with a reflow. All right. Doesn't corrosion under one chip make you suspect the other chips too? Well, it depends on how widespread everything is. That is a very, very, very small area over there. That's a really tiny, isolated piece of corrosion. Now, it does make me question the chip next to it, for sure. And we may just give a reflow to both. Luckily, we have a flux budget that allows us to reflow both of them. Yeah, so luckily the flux budget here is actually very liberal. We're like Congress when it comes to flux. Spend, 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 baby. Inflation is transitory. Fuck your puts. Something like that. Go with flux. Now you go over to the one next to it, just for the hell of it. Give it a little tap. Now, I'm going to have to deal with those resistors over there. I don't like those resistors. That looks like shit. Yeah, as you can see, I took the soldering iron away from the board. And even though I took the iron away from the board, I was able to just easily remove that resistor with my tweezers, so that was not conducting anything. So this means that the data line between U2800, or yeah, U2800 and the CD3215 was not working at all, because this resistor was not even physically attached to the motherboard. And I also am probably going to take the resistor under it off with me. As well as you could see, I was barely touching the resistor under it, and that went away. Now, one thing I want to do is I want to see if I can save that pad, because I really don't have to I really want to avoid running a wire underneath the chip. So I'm going to try and save the pad. I'm going to see if I can save that pad. There's a gentle scraping. Okay. Now, one of the pads in the right, that was the one I actually thought was in better condition, appears to not be there right now on the top resistor. So this is going to be fun. Let's just do a little bit of scraping over here. Okay. But as you can see, when I get rid of the flux, even though my pad is missing, I may be missing the pad. I have this pathway over here that was leading to the pad. So what I can do is I can scrape this and then run a jumper wire and then create a pad. So that's what we're going to do. How much is your flux budget? Approximately $12,500 a month. Now you figured out why I'm behind on my shop rent by $92,000. It's because of the flux budget. Stick-on pads are an absolute waste. For at least what we're doing here, it's useless. It's not practical. No point. In 7 years, we've had repairs come back for different reasons. So for instance, like let's say we do this, but the CPU dies or something else. We've had that type of thing, but we've never in 7 years had we soldered a jumper and the jumper, came off or something. That's not going to happen. If you drop the machine in a manner that makes a competently soldered jumper come off, your machine is probably going to look like an accordion, so at that point it really doesn't matter anymore. That's not a thing. I know that Apple's response to the Wall Street Journal piece is that they found out that single component replacements were not reliable. That's why they don't do them. If that's the case, then I'm really curious why it is when they replace boards for customers, they give them refurbished ones that they've refurbished themselves rather than new ones. But I definitely ignore all of your chat, Nomad King, and I will continue to from now until the end of time. It is Big Rude Dude. Florida's still on my list. I gotta visit a lot of areas of the country, but first I gotta do this damn Massachusetts trip. I gotta get this Massachusetts trip out of the way, and then I can go up on and visit other parts of the country. It's also going to be important to have an idea of what types of places exist in case my landlord wants to play hardball and say, no, sorry, full rent, going forward, full back rent. I don't know if that's what's going to happen. We'll see. There's only one way to find out, right? One way to find out. Okay, I gotta put my little jumper over here after I solder this resistor on. Alright, now we have to solder a jumper wire. So I have my little jumper wire over here. You're right, Inexio. They don't change components sometimes. Sometimes they just use a sticky rubber pad. Don't remind me. These are the people that we have to defend ourselves to when it comes to our ability to do our job. Hey, Lewis. I have a laptop repair shop because of you. That's awesome, GD Tech. I'm glad to hear it. I hope it's very successful. I wish you most of success. Hopefully less failure than I've experienced over the years on your way to it. That little jumper is going to get into place if it kills me. Don't you think you're getting away from me, you little jumper wire. Alright, this is the fun part. And this is why I retired. Okay, scrape. Fuck. Okay. Make that top piece melt in again. Ah, shit. Okay, take two. Take two. We're in. Let's get that bottom of that resistor onto my soldering iron. Get that out of there. I can see the bottom of that resistor in there. I wouldn't have the patience to do this type of work. This is why I'm looking up to people who can. They're just built different. I don't think I'm built different. I just think I'm willing to humiliate myself more. Thank you, Nomad. I appreciate that. Let's gather a resistor from the donor. Okay. Get this in a focus. Lay the resistor down. And get our jumper wire. It used to be easier to do. Okay. Now, what we are going to do here is we are going to prepare our jumper, scraping away the enamel on the jumper. We are going to scrape away the enamel on the jumper. Get rid of this thing over here. Now that jumper goes to this probe point. So first thing I'm going to do, I'm just going to anchor it to this probe point over here for a moment, just to make it easier to run. And add some flux. Now I want that jumper to make as much contact with the resistor as possible. So I don't want the jumper to run up here and just touch with its tip. I actually want it to touch it at an angle like this, at a right angle. Because if it touches at a right angle, then it's making more contact with the resistor, and it is less likely for have anything bad happen to it later. Okay, that's good. Lewis, you are my favorite philosophy New York City real estate component level repair video creator. Can I offer your car an extended warranty? No, but you could offer me cheaper insurance. As you can see, my wire is a little longer than it should be. I'm going to solder it back around there, in which I did. Now last up, on this probe point over here, I don't want to have a gravelly probe point. So I added a little flux. Bada bing. Now the thing is, thanks for helping us to fix our junk. Thank you. Now here's an important thing. There's something called surface tension. So I have gotten considerably worse with the handling of my hand and being able to solder things and make micro movements and micro accurate movements, particularly a lot in the past year. It's been going on for a while now, but a lot in the past year. So I'm not able to get that exactly where it needs to be. However, through the magic of surface tension, I don't have to. Once I've gotten it close enough, I can just reflow with my hot air station, and that wire, that jumper wire and that resistor are going to find exactly where they want to go, and they're going to sit in place exactly where they want to be. So rather than it being stressed or in a position it doesn't want to be, I'm going to heat everything up here to put it in the position that it does want to be in. Wait for it to dry. Now this jumper, again, it's not just making contact at one point. It's actually making contact at a right angle, so it's making contact with the entirety of the resistor, which is what I want it to do, which is going to be a slight, I would say, a superior connection to if I just ran the tip of the wire up to the tip of the resistor. That's why I ran it in that particular fashion. And because I have OCD and can't leave well enough alone, I'm going to give it one final tap before I plug this in and see if I made any progress. And indeed, I lifted it off the board. Now, when you're done, just allow it to be done. Okay, I'll hot air that back into place. A moment here. Just tap that down onto the board. I want it to be flat on the board. It's important to me that that point be flat on the board and not be sticking up. And now that's done. Okay. Now I'm going to allow this to cool using rapid cool technology. Beam extractor. Bada bing. Rapid cool technology is in session. Yeah, holding this wire used to be a lot easier for me than it is right now. Sucks. Yeah, I could see it moving even when... My hand is moving even when I'm all the way zoomed out. Oh, well. Fuck it. Okay, so... Next, let's see if we've made any progress. So the board is now colder. I'm going to plug it in and see if we get 20 volts. You think we got 20 volts? One way to find out, right? Plug it in. 5 volts. 0 amps. Okay, that's different than before. And over here, we get 5 volts, 600 milliamps. 600 milliamps is a bad. That's too much. And over here, you get 5 volts, 20 milliamps. Interesting. So before we had 5 volts, 15 to 20 milliamps. Now we have 5 volts and 600 milliamps. Now let's see which CD3215 goes to which charge port. So I'm plugged in to the bottom charge port right now. We're going to take a look at this section. Now, obviously, one of these CD3215s is going to be boiling, and I'm kind of curious which one is the one that's going to be boiling, because it's taking 600 milliamps. I mean, 600 milliamps is hot. So one of these is probably going to be noticeably boiling. And as you can see, the one that has the alcohol evaporating from it seemingly faster, let's see if I can, is the one on the right. Yeah, the one on the right is burning, which also makes sense because that is the one that's hot. That's the one that had the corrosion on it, I should say. So what I'm going to do is I'm going to remove that chip, and we are going to replace it with another one that you can get on store.rossmangroup.com. All right, so sometimes you can reflow a chip, sometimes you can't. Now, the corrosion next to it was very clump-like in nature, so you're probably going to see that when we remove the chip. You're probably going to notice what looks very clumpy under it on the right side where the corrosion was. You're going to see the pads. You're going to probably see what looks like some nasty dirt under there. I just pulled the Paul Daniels there. Did you see that? Oh, sweet mercy. That was a total Paul Daniels. Remember when he did that with the SMC? Never forget. I'm never going to forget that. Sweet mercy. I love Paul. I hope they let him out of Australia someday. Now I'm going to put some lead solder over here to suck up all the lead-free solder balls. It'll make it easier for me to wick. The board is moving around the desk, which is very strange. It's not sitting flat on the table. Okay, so before I put the CD3215 on, I would like to straighten out this resistor. Now that I don't have a chip in the way of it. I know this doesn't matter because I soldered it to the probe point, but it's highly triggering to me that is sitting like that. Better. The quality of the solder on this the pad of this resistor is shit. You can make that better. Much better. If we can have a moderator ban Die Carly from the chat. I'd highly appreciate it if there is a moderator in the chat to ban Die Carly. Thank you to Mr. Hi Hi. Lame jokes from people that are not funny. Okay. Now we're going to get a CD3215 to put over there. Okay, we've got a replacement CD3215 chip. We're going to put this chip on the board. Put a little bit of flux. Get the balls of the chip all up in that flux. Now, when putting a BGA chip on the board, one thing that you want to do is to make sure that you have it in the right place is you're going to tap in the center and you're going to scratch it. And when you scratch it, once it's only moving the diameter of a pad in distance, you're good. But you have to wait until it's not moving more than the diameter of a pad to know that you're good. And now we're going to solder it on. So my hot air is going to be further away from the board when starting. Start preheating the board, preheating the chip, preheating the flux. Okay, it tried to flow away there. Nice try, mofo. We went in for the kill too quickly. Keep heating it from further away. It's like being a snake charmer. Charm that snake. Yes. Yes. Now dance. Beautiful. Rapid cool. Five volts, 20 milliamps. Oh, 20 volts, baby! Woohoo! 20 volts, 500 milliamps. And on the other port, you get 20 volts, 500 milliamps. It's turning on. That's what we do, baby. We make MacBooks work again. That's it for today. And as always, I hope that you learned something. So what was wrong with this board? This board had corrosion on the CD3215, particularly around two resistors that allow it to communicate with the USB-C and Thunderbolt controller at U2800. We replaced the resistors. There was a bad trace under. It was not a bad trace. There was a bad trace between a resistor and a probe point for it to go to the other side of the board. So we had to run a jumper wire, which I suck at now, but I did anyway. And we also replaced the CD3215 because once we had run that, once it was able to speak with the other chip and actually turn on, it was taking 600 milliamps, but stuck at 5 volts. The chip was also getting fairly hot. We replaced it with another one available from store.rossgroup.com, and now it works. Now, why is right to repair important? Because I was able to fix this board, right? If you had a 2019 or 2020 model that uses a CD3217, I can't, because that chip is not available. And I'm not able to call up Texas Instruments or Mouser or DigiKey or Newark or anybody else and buy that thing. Eventually, I'll be able to once it gets leaked from somewhere, some source in some far-off land. But for now, I have to, turn down this repair, which would otherwise be a fairly basic and easy or simple repair that would last for a very long time, work very lovely, because of chip unavailability. If you want to learn how to do a lot of this stuff, we do have a link down below to a very, very long guide that explains how all of this stuff works. Let's just see if I can bring that up on the screen over here for you all to see. If you're interested in board repairs and stuff like that, there's a nice guide that explains how to do everything that I do. Is a beginner's guide. And there's also in-person classes. So let's bring up all this stuff. So we got a beginner's guide. We have the repair wiki. So if you're interested in this stuff, first you have repair.wiki, which I'd highly encourage people to contribute to. If you have ideas on how to make this better or devices, don't ask. Don't ask, Lewis, can I add? Just add it if you know what you're doing. You have for this machine, you have a list of problems and solutions. You have the amazing Jesse Cruz at VCC Board Repair, who is kind enough to start contributing information on iPhones. And as you can see, the iPhone 7 guide on here is just out of this world amazing. Beautiful contributions to repair.wiki. We have this training guide, which will be linked down below. This training guide is a 150-page guide that goes over a lot of the basics, and it eventually goes over, a lot of basic electronics. Then it starts getting into MacBook circuits, basic mistakes that people make when they're trying to, figure out which capacitor is bad when there's a short circuit. But it goes over what a lot of different components do, how transistors open, what a voltage divider is, pull-up resistors, diodes, data lines. Let's see. What causes a power rail to not show up, what the different power states are, like S5, S4, G3 hot, all that other stuff. It goes over, like how to power an integrated circuit. It goes over what a buck converter is, what it looks like, and it tries to make all of this stuff really, really simple. I tried to make this guide as simple as humanly possible. It's got a lot of pictures, but above all, this guide is available for free for anybody who wants to take a look at it and learn. And we also do at rossmangroup.com. We have classes, so if you want to sign up for a class, we have paid in-person classes. But everything I go over in every single one of these classes is the exact same stuff I go over in these YouTube videos. It's the exact same stuff I go over on this sheet. It's the exact same stuff that I go over on the Repair Wiki, which is all freely available for someone who doesn't have the money to pay to learn, or who can't afford to stay up until 4 a.m. every single day trying to figure it all out for themselves, the way I did throughout most of my 20s. Anyway, that's it for today. I hope you learned something. It's a pleasure doing a board repair video with you all. See you in the next one. Bye now.